Okay, so we're talking about cyclonic precipitation, kind of going off from what we talked about yesterday and all the rest. So cyclonic precipitation, again, is driven by the collision of air masses. So in the picture here, so there's a bit of a blurb here, all the rest, but in the picture here you see a warm air mass coming up, following kind of probably the westerly wind pattern, blowing up into the mid-latitudes, colliding with a cold air mass, and that cold air mass then creates a bit of a cyclonic effect, circles around and overtakes, or circles around and comes in from behind and ultimately closes this gap. So eventually the warm air will all have been forced to rise, cool, condense, and fall, and the precipitation event will be over. So again, you can see another visual here. You got a cold air mass colliding with a warm air mass. The warm air mass typically moves slower, it's stickier, more humid, all the rest. So it collides with the warm air mass, forces the warm air mass up into the air, cools, condenses, and falls. Here, this is an over-the-top visual, like a bird's eye visual, whereas this is your panorama. So the bird's eye, the warm air mass rides that southwesterly wind pattern, collides with colder, denser air, and that colder, denser air creates a cyclonic effect, which closes in behind, and ultimately, like I said, closes this gap until the warm air mass has been neutralized, let's say, or has been, the warm air mass has, the differences in the characteristics between the two air masses has been neutralized. So let me straighten you out a little. Okay, sorry. So we go to the back here and we've got a chart. So this chart, although it's difficult to view, a static image, let's say, and then take it as what's going on in the overall process. But if this is our image, we've got overall predominant wind, let's say, sorry, that wind is not written very neatly, but pushing this overall system that way. So you've got a few different air masses here represented by these lines. So a cold air mass, we're going to just label right there. We'll say that's the cold air mass. Okay, so this is the warm air mass, and we'll call this another cold air mass. Okay, so again, if we go back to our other side here, what we have going on is that a warm air mass has followed this westerly wind pattern up, collided with the cold Arctic air, which is circling around and behind, creating this cyclonic system. Okay, so then we go to this, and again, so now the warm air has collided with the colder air, and now the cold air is circling around and coming in behind this warm air and trying to close off this distance. Trying to close this distance so that you get rid of the differences between the warm and the cold air. Okay, so we can do some basic characteristics here. And so the basic characteristics of a cold air mass, the temperature would be lower, obviously, right? You could say colder, cooler, lower, whatever you want to say. And the warm air mass then would obviously be warmer, higher, whichever works. Typically when you have warmer temperatures, you have higher, lower pressures. You should remember that you have lower pressures when you have higher temperatures. And when you, obviously the opposite side of that then, when you have lower temperatures, you'd obviously have higher pressure. Okay, so we're rolling here. Okay, so let's just, I guess, complete those two. So when you have warmer air, you have lower pressure. Lower pressure means that that air is, let's say, more volatile or more likely possible to rise. So if it's more likely possible to rise, then you might possibly get more cloud cover based on the air's ability to rise. When it cools, it condenses the dew point to form clouds. So what you get in warm air masses, typically you might get a clear sky, not necessarily a clear sky, but you'll get an overcast sky, which is some in combination between no cloud cover and tons of cloud cover. When you have air rising, warm air rising, which creates an overcast sky, might it rain? It might, right? So it's not like it's going to rain, but if the conditions are right, that the air is going to rise, cool, condense, the next step is fall. So the air could rise, cool, condense, and fall. It's at least going to rise, cool, and condense to form overcast skies. And if the overcast sky contains enough humidity or the atmospheric conditions allow for it, you could see some precipitation. So now we go to the opposite side of that. If you have colder air, that colder air is going to be less likely to rise. When it's less likely to rise, this high pressure is going to hold it down to the ground, which is going to create what type of sky? A clear sky, clear blue polychromatic sky, right? Precipitation, when you have a clear sky with minimal clouds, unlikely. Is it possible? Sure, it's possible if conditions allow for it, but it's not necessarily likely. Now, sorry, 1 second here. I want to tighten this. Sorry. Deal with it for a sec. And I want to turn this. That should work a little bit better. Sorry, it was bugging me. It's probably bugging you too. Okay, so now we have 2 things. We have 2 columns done, 2 to go. So now we're in the collision zones, the boundaries. So again, just above this line will be more warm air. If you notice, there's 2 different shapes of the line. Let's say the warm air mass is riding up on top of the cold air mass. It's a slower process. This air mass, the cold air mass, is just hanging out. And the warm air mass has, again, if we go back to our visual here, the warm air mass is riding that westerly wind, southwesterly wind, colliding with this. So it's the one doing the movement, let's say. Well, they're both moving, but it's the one doing the movement. So it's a more gentle, slowly but surely rise up over the top of this. As it rises up, it's going to lose its humidity. It's going to lose its moisture air content. I'm making up random words there now, sorry. It's going to lose its humidity, and it's going to have some sort of precipitation event. You go to the other side here now. This is obviously, let's say, a more violent line. I always picture a bit of a bulldozer type shape. And so that bulldozer is closing around back, just like we went to the previous visual. It's circling around behind, and it's going to try and close this gap every time. The more closed the gap is, the more uniform the air characteristics are. So as it tries to close this gap, it literally forces this warm air up violently. Okay, so slow, gentle ride of a storm, precipitation event, and violent, fast-moving, over fairly quick type of storm. Okay, so I always find it somewhat difficult to visualize it on this type of a shape, but I think the easiest one would be to picture yourself as a person. Sorry, there's my stick person there. So you're a stick person there in the warm air mass, and then the cold front, the front of the cold air mass, passes over top of you. So you go from in the warm air mass through the storm, and then you end up in the cold air mass with entirely different conditions. So if we did the other side of this, you're in the warm air mass, the more gentle storm passes over you over the period of a few days, and then you end up in the warm air mass. So these are kind of your transitions between warm going cold front to cold, and cold going warm front into warm. So let's get rid of some easy ones here now. So the temperature, you'll see the trend when we go through this. The temperature, you're obviously in this air mass and ending up in this air mass. So we're going to say it goes warm to cool or colder, and it's going to do it relatively quickly. Cold fronts come through, and they happen in the matter of a few hours or something like that. A few hours, possibly towards a day, something like that. I guess I could have done that the whole time, but we'll be okay. Okay, so now the pressure, you're obviously starting here, and you're ending up there relatively quickly. So we're going to go low to high, and we're going to do that relatively quickly as well. Okay, so at this type of storm, this warm air mass, the warm air is going to be forced upwards relatively quickly. So you're going to get your tall, dark, and scary clouds, and you'll see the building of these clouds. Anytime you get a tall, dark, and scary cloud, the precipitation event is going to be fairly heavy. And what's that? So the precipitation event is going to be fairly heavy, and anytime you have massive changes in air, you're going to also get some scary lightning, which is going to make this person's day pretty bad until they get into here. So this will take a few hours, maybe a day to pass by. So you go from warm to cold quickly, low to high quickly, and you end up from this air mass into this air mass. So the sky cover, these tall, dark, and scaries have a name. The cumulus clouds. I hope I spelled that right, I'm not 100% sure. And then they change then from cumulus to cumulonimbus. So we're getting pretty complicated with the words here, but that's okay. So cumulus cloud is a puffy cloud. think that's the easiest way to memorize it, is a puffy cloud. It's the one you pick out as a dragon or a sailboat or something like that when you're a little kid laying down and watching clouds go by. Cumulonimbus is the suffix or prefix nimbus, don't ask why they switched it around, that just simply means rain. So a cumulus cloud is a tall, dark, puffy, possibly scary, and cumulonimbus is a tall, dark, puffy, scary cloud that is raining. Okay, and the downpour that you'll get is what's exactly that. It's a downpour. So torrential, downpour, absolutely insane precipitation event, whatever you want to call it. But over fairly quickly, and then you transition into the clear blue, higher pressure, unlikely precipitation until the next air mass moves through. So now we go to the other side here, and what you get when you get a cold air mass hanging around with a warm air mass colliding into it is you get what's known as, so this will be your warm front, and this will be your cold front. But you get a warm front, and a warm front moves through, you get slightly different conditions. So here we're obviously going to go from cold to warm, but it's not going to happen relatively fast. It's going to happen slowly. Now that slowly is instead of a few hours, an evening, this is going to be over the course of a few days. One day, few days, few hours, multiple hours. The pressure then is obviously going to go from high to low, slow. I think if you're absolutely stuck and you're memorizing this, even though you shouldn't really have to, you should be able to piece it together just based on previous information and all the rest. There's your key to the whole thing. High to low, slow. It rhymes. I think it's easy. Okay, what you get here is you get stratus clouds. And so let me just turn this for 1 second. My visual stratus clouds are just going to be, that's how I like to visualize them. I don't know if they work for you. But what they are is sheet clouds. And I drew this earlier in a previous video, but they're sheet clouds that kind of cover the sky. Basically, the whole sky is gray. It looks like someone pulled a gray blanket over top of the sky. And what you get there is not a torrential downpour, you get periods of rain, episodes of rain. And what's the prefix or suffix that means rain? Well, you guessed it, it's nimbus, right? So cumulonimbus. Okay, so instead of doing stratonimbus, which makes too much sense, they go and do this. Does it matter? Not at all. But instead of making it a suffix, they made it a prefix. Okay, and instead of having torrential downpours of rain, you'll have the opposite of that, which is, maybe not the opposite, but sporadic, or I like to think of it as episodes of rain. So these are the days where you walk outside and it looks like it might rain, wants to rain, might not rain at the same time. It's the windbreaker days as opposed to the umbrella blowing away Mary Poppins type days. Scary Poppins maybe. Okay, so overall what happens when you have a warm air mass colliding into the cold and then the cold air mass circling around in behind and driving up that warm air mass?